Thank you, Russ. Okay. See if I can jog the slide here. Okay, going into definitions. So just wanted to lay out some definitions, try to clarify some things. There's a lot of buzzwords going around in industry. So we'll go through some of that and try to make it more clear for you. But when we're talking about an industrial robot, according to R1506, the standard defines that as that's only the robot arm and the robot controller. So, you know, a lot of people say, yeah, I got this robot I need to safeguard. Well, just so we're all on the same page and we're very clear, we like to take a system approach. So the industrial robot system would include the robot controller, and the end effector. So end effector is very critical when we're talking about safeguarding a robot. And then it goes even further. It goes into the industrial robot application, which is, there's the end effector. The industrial robot application would include the workpiece and any ancillary equipment. Maybe it's the workstation, how the application is laid out. So just important here, when we say robot, well, per the standard, that's only the robot arm and robot controller. So we really want to take the system approach and look at the entire industrial robot application. So let's talk about some trends. The traditional safety paradigm, traditional way to safeguard robots is to isolate the person from the robot. So separating the person from the robot, you know, it's pretty typical to use some form of hard guarding. Maybe you interlock the door, maybe use a light curtain or other presence sensing device. But the key here is anytime the worker attempts to interact with the robot or enters the robotic cell, we enter a protective stop. So there's no power to the cell when we're working inside. So the main idea here is that in years past, we do a full stop. And what we're seeing now in industry is an increased human-robot interaction. So this is often called collaboration. And we all know the driving factor for this is increased productivity. So now a person can work in a shared workspace or maybe directly with the robot. And this is what the standards call collaboration. Now it's a big buzzword in the industry, but per the standards, what collaboration means is there's some sort of safety rated monitor stop, or you're using manual control or hand guiding. Number 3 would be power and force limiting. And 4 is speed and separation. So those are the 4 modes defined by RITR 606 for collaborative robots. Those are the 4 modes of collaboration. So maybe the picture in the top left would be safety rated monitored stop with limiting some sort of position. Bottom left is probably all 4 modes of collaboration. So safe stop, he's working directly with the robot, so that's hand guiding. The robot probably has PFL, and it's also using speed and separation. So any combination of those 4, and we would call that, per the standards, a collaborative application. So that's what the standards define it as. And the confusing part is the industry uses these buzzwords differently than the standards do. So a collaborative robot by itself does not mean a safe robot. So when I want to go out and buy a collaborative robot, we often hear, well, it has some engineering controls built in, it's inherently safe. So not entirely true. We go back to the definitions and we say we want to look at the safeguarding the entire application. But what these collaborative robots do have, a lot of times their joints and corners are soft, rounded, and they have smooth surfaces. So if you do come into contact with the robot, it's less likely to harm you. And also when we talk about, hey, I want to buy a collaborative robot, what that usually means is that the robot has power and force limiting capability built in. So in industry, a collaborative robot typically means it has soft corners and it's PFL. Per the standards, previous slide said that any robot that is used in those 4 collaboration modes. So a little bit confusing for the standard and then what the buzzwords are in the industry. So trying to clarify that for you. So that's why we often say, you know, when we take the system approach and do a risk assessment, there's oftentimes a bunch of additional protective measures that we would want to have built in. So let's go through an example. This is 2 robots, maybe doing some processing, and then in the upper left, once that processing is complete, robot 1 will be interacting with that person who's accessing the parts on that rack. Let's say maybe that person only interacts with that shared workspace maybe once an hour, but obviously getting hit by the robot, severity would be high. Maybe, you know, it could cause death or permanent injury, and then it could be difficult to avoid the interaction with the robot. You know, it could be difficult to avoid a swinging robot. So some of those last few words that I just mentioned might sound like you're talking about a risk assessment. Per the standard, R1506 says you must perform a risk assessment on a robotic cell. Important thing here is we're determining the required performance level. So as I said, you know, there's many ways to perform a risk assessment, but some of the key factors we're looking for are severity, frequency or exposure to the hazard, and then the possibility that you could avoid that hazard. And as we said in our example, without any safeguarded measures, getting hit by the robot could cause serious injury. So that would be S2 for serious. Frequency, maybe he's interacting with the robot only once an hour. We would categorize that as seldom. And then possibility to avoid interacting with the robot is scarce. If he's in that area, he's going to be interacting with the robot. So in this example, we follow the chart and our risk assessment says, hey, for that safety function, we need to meet performance level D. In this example, it actually fits the standard pretty well because our 1506 directly says that all robots need to be safeguarded to performance level D. So there is the following clause in that standard does say you can use other performance levels, but you must specifically have that documented in your risk assessments, and all of your safeguarding documents must prove out why you chose a lower performance level. So in industry, we see a lot of robots being safeguarded to performance level D just to satisfy that requirement. But how do we know we're reaching performance level D? So let's go back to the application. Maybe the risk assessment said, yeah, let's safeguard this with some light curtains. That's the best way to let the person interact with those racks. So safety devices, light curtain, maybe a safety PLC or some other safety controller, and then the robots or the outputs to the robots. So per 13849, we define our safety function as inputs, logic, and outputs. And let's see how we stack up with our performance level. So we can get this information from the manufacturer. Our light curtain reaches performance level E. Same thing with the logic. We can get that from the manufacturer. So that's performance level E. And then commonly, our safe robot controllers are rated for performance level D. So in this case, our overall rating would be following the weakest link. So we would get an overall rating of performance level D. So that's good. We said our performance level required was D. We're meeting that. So this is just the typical thought process when you're going through your risk assessment. You're choosing how to safeguard your robotic application. Just some other things to point out. We often hear, hey, I need a light curtain because I need to reach performance level E. So just keep in mind, a lot of safe robot controllers will have a rating from the manufacturer of performance level D, especially when you're using like a safe motion package. Those are often rated performance level D. There are some out there where if you need performance level E, you would often only be using a protective stop, so they wouldn't have the safe motion package. And then we'll just touch on some specific robot-specific standards. So we really have two stories here. We have the international standards, so ISO 10218. There's two parts to that standard. The first one would be requirements for the manufacturer. Second part is requirements for the integrator. So I guess the important thing to note here is that the user is left out in these standards. So, but it does recommend that the user is heavily involved with the risk assessment. Their input does matter, and it's also important for the user to understand some of the requirements that are put on the manufacturers and integrators. Then when we go to the U.S. national standards, it's pretty simple because ANSI RA R1506, the 2012 version, was a direct adoption of the international version, so they're pretty well aligned. And then this standard is actually due to be updated sometime in 2022. And then what RIA put out was a bunch of technical reports. So technical report 306 goes through the risk assessment, 406 is safeguarding, and so on and so forth. Another thing that's important here is that 706 actually does talk about user responsibilities. So that could be a good technical report if you are an end user. 606 is a direct adoption of the international standard for 15066, collaborative robots. So those two are aligned, and those are some of your applicable standards for robot applications. So with that, just a preview of some of the technical stuff. I'll pass it over to Russ. He'll talk about how to solve some of these safe robot applications with some of our packages from SICK.
Thank you, Jake. Does my screen have a big old gray blob in the middle of it like yours did all the way through? Jake?
No, yours looks good. I hope mine wasn't showing for everybody.
It was, I think, but it was, I'm not sure what was, I think you're only using one screen, so it's all good. We could see all your content. Okay. So my name is Russ Nikodem. I'm joining Jacob here. I'm going to be talking about the product that we would use to meet these standards. Most of our products fit into the speed and distance management when we're in the robotic safety versus the force and power limiting. So we'll jump into this. We have a couple of different families of canned solutions for safeguarding your robots. So get up in here. You can see my screen. First thing I want to make sure is clear that we work with almost all the different, we can work with all robotic brands. The ones we work most closely with are Fanuc, Yaskawa, UR, ABB, and KUKA. We have specific kits available for these specific manufacturers. However, we have generic kits as well. So the difference is when you get a generic kit, you may not get the exact instructions that tie exactly into a KUKA. You might have to interpolate these. They may call the safe stop, protective stop something different, or the emergency stop something different. So that would be, you wouldn't have those specific instructions, but we work with almost all robot manufacturers. What we're trying to give you is increased productivity. We're trying to give you free access to the robot application. We're trying to get away from the locking the robot behind a big old fence and locked doors. We want to be able to work with the robot collaboratively or cooperatively. We're working to give you easy integration. We want to give you the hardware, the software, and the package put together with instructions so that you can easily deploy these kits in your manufacturing facility, or if you're an integrator, you can have consistent kits to provide to your end customers. We have the support for you. All these kits come with instructions. So what do we have? sBot stands for Safe Robotic Systems. If you look from left to right on the bottom here, we have sBot Stop. that's your most traditional robot. It's just all your robot does is stop and start. You walk into the cell, the light curtain detects you. You go inside the cell, the robot stays stopped. When you exit, you either have to push the reset button or it automatically restarts. Then we have the sBot speed, and the speed is where we get to have the custom function blocks with sequencing and things like that built in. So this starts to get more sophisticated when I'm into the speed. So we've got the sBot speed and generic. That's where if we didn't name one of the robots above, Fanuc, Yaskawa, you'd use a generic kit. We have a kit specifically for universal. That's how we started. And a lot of people think, well, if it's a universal robot, it's collaborative. It doesn't need any safeguarding. Well, this goes back to Jake's point where the universal robot uses power and force limiting, but when you put an end effector on there, you may also need speed and distance monitoring as well to keep people away as a system. So you may need both protective measures even though the robot is collaborative. We work very closely with Fanuc as well. And part of my presentation, I'll dive into the Fanuc just because it's one of the more common robots in a little bit. So first of all, the stop, sBot stop is very simple. You've got a light curtain here. It's your primary protective device, and then you've got a laser scanner inside your robot cell as your secondary protection. That's mainly restart inhibit function. So if somebody walks in, it's monitoring that somebody's inside the cell and nobody can restart the robot. The working principle, these are either manual or automatic restart. We all know what that means, so I'll jump past that. You can either have it when you exit the cell, you have to push the reset button or not. What we're giving you in these very simple, the stop, sBot stop is laser scanner, light curtain, a control module with your logic built in. So the idea here is that you've got the hardware kit and you've got your logic built in, so you don't have to write any logic with these kits. Some of them you may want to, you can modify them, but the base logic is all written for you. In the sBot stop, you've got your reset, your emergency stop, a Flexi Classic module which doesn't use any software. It's just dip switches, laser scanner, light curtain, and then that ties directly into your robot controller. And then in the robot controller, you'll either have your emergency stop or your protective stop or both. So it's a very simple, this is very simple, basic robot protection. To Jake's point, the safety functions are available through pre-engineered and tested safety logic. Well, that was my point. These are simple and easy to deploy. Here's where Jake was talking that most robot cells need to be performance level D. The components and the software and the kit are performance level D rated. In most cases, you get detailed documentation to tie it into your robot, which makes it really simple for you. And we work with most robotic brands. So from that was the stop. So now I'm jumping into the sBot speed, and I realize I'm going relatively fast because a half-hour seminar doesn't give you a lot of time. So we're looking at the sBot speed SIP. What does SIP stand for? Is the safety over the network. It's Rockwell, it has Ethernet SIP safety, SICK has Ethernet SIP safety, and the Fanuc robot has Ethernet SIP safety as its backplane or its safety network. So none of the inputs and outputs are done over wires, it's all done over the network. The idea behind the sBot speed is that you're able to keep your robot working with your person. So your person and they have free access to the robot. So a person can walk into the robot cell and the robot will know where that person is via the Ethernet SIP safety, slow down, move to a different quadrant, whatever you have programmed in the robot. And when they get too close, they'll come to a controlled stop. And if you look in this little corner on the side here, if the guy goes to what I would call the no-go zone, where an area where they just shouldn't be, it'll automatically go into an emergency stop, which means then you need to have a reset. But if the person on the right here, if he's working with the robot as he should be, that's called cooperation. The robot will do its thing, keep working. The person can walk in, do his thing, keep working. As he backs out, the robot, keeps going. You don't have to be pushing reset and having the robot completely come to a complete stop. There's a quick video coming up. So the idea here is that you got unlimited free access to the robot. That's huge. You have simple and low-cost integration. These kits are standard products off the shelf. The only thing that's different about the sBot Speed is that we have a custom function block that we have built in that allows us to do sequencing, which is required by the RIA standards. The idea is to reduce downtime, increase efficiency. It's reliable and safe, of course. These are sick products. We're always reliable and safe. They're super flexible. We don't lock it down the program. You can change it as you need. And it's very future-proof. If you want to add more lasers, you want to add, change your program, you're free to do that. So at the base of a system, you have a safety laser scanner, a safety controller, and then over a network, you're talking to the robot. The safety controller is acting as your master, and your robot is the slave, and your scanner is the slave. So somebody's got to be the master or the host, and the others are the guest. And then all of your other devices, your reset, your restart, your emergency stops can tie right into your controller. But the beauty of this is there's no wires going back and forth. It's all Ethernet SIP safety. So in your kit, you get an sBot SIP hardware kit. You'd have your FANUC robot, and then you'd buy your safety command devices, and they all tie together into one complete system. This is just another way to look at it. You got your software package. Your software package is downloaded from the internet. You get your Systema files. You get all your logic, which is very extensive logic. You even get your safety laser scanner program in this download. So you've got your scanner program, your FE Pro is what we call Ethernet SIP safety. Then you get your operating instructions. So you've got a very comprehensive kit here when you buy this system. I'll do a quick video of the working system, which would be very similar to what I have sitting on my desk here.
Welcome to the Tech Desk of Russ Nikodem from SICK Incorporated. Today we're going to be talking about an sBot. So what is an sBot? An sBot is a safety robotic area protection kit. It combines a bunch of our technology into a comprehensive safety robotic kit. So it includes a safety laser scanner, safety controls, whichever controls would be applicable for your robot. You normally have the e-stop and reset buttons incorporated in. It has the program for the laser scanner, the program for the safety logic, which is specific to your robot. This is called a Speed because it has custom function blocks built in. So if you notice here, I have a yellow zone, which is my warning zone, which is my slowdown zone. I've got a protective field 1, and I've got a protective field 2. So the idea here is that your robot can have free access to it, and the controller has built-in logic so that when a person enters the robot cell and they get into the first warning zone, it uses speed and distance separation as a safety measure. It sends a signal to your robot to slow down. You notice that your robot now is going very slow. That takes this protective field and it shrinks it because it gets feedback from the robot that says, hey, I've slowed down. So now my person can work around the robot much closer because the robot is moving slower. If the person gets too close to the robot, it still stops. You can see that it stops, and the person does his chore, and as he backs out, into the warning zone, the robot automatically starts back up. That's why it's called a speed. It has sequencing built in. And as he backs out further, when he exits the cell, the robot automatically goes back to full speed without the need of pressing the reset button. So you say, well, what happens if he breaks the sequence? So the person comes into the cell, and he's working around, and something drops, and he goes into the protective zone. And if he breaks the cycle, you'll notice that my reset button comes on, and the automatic restart is gone. So then when he leaves the cell, he has to physically check the cell to make sure everything is okay and push reset. So that's what the custom function block is doing. It's doing the sequencing. Once again, he allows the person to come into the cell. The robot slows down, allowing him to work around the cell. And when he gets closer, it stops. And then as he exits, it goes back to slow speed and then ultimately back to full speed, increasing your productivity. So that's at the heart of the sBot suite. Thank you, and have a good day.
Yeah, so that's at the heart of the speed, sBot speed. So we're trying to get, once again, is safe productivity. By using these kits, at least as the base kits, you can modify them. But what people really like about them is that they've got a baseline. You've got a program that's written for you. It's written to performance level D. You've got hardware for performance level D. So you've got a very good system that, especially if you want to repeat over and over and over, you don't have to rewrite the software. The safe sequencing is very critical in these applications. Needing to know where the person is and is coming into the cell and leaving the cell is very important. So one thing I'll show you real quick. So what do you get when you download a sBot speed package? You get what I have on my screen. You get the sBot speed PDFs, which is the operating instructions. You get demo E-plans, more demo E-plans. You get your safety designer program, which is really, see if I can open it quick. I got about a minute. Just wanted to give you a flavor for what you get when I talk about having the program built in. Coming. I call this what's under the hood, if we can get to it. Okay. So this gives you your your FlexiSoft controller. It's got your tie-in to your FANUC robot, and it also gives you your tie-in to your laser scanner. Come on. Doesn't want to come up there. When I look into this, I just wanted to show you what you kind of get for your logic. They break down the logic very well for you. You've got your inputs and outputs, your emergency stop page, your protective stop, safety rated monitoring speed, your safe sequencing, your robot safety signals are all done for you with little nice notes, and your robot non-safe signal. My point in showing this to you is it could take you a week to write all this logic. And if I had 10 different engineers writing this program, you would get 10 different versions. So the beauty of this is you've got a very good baseline for your robotic safety. So with that, we're out of time. I went a minute or two over, but I thought it might be important to show you what you do get from this software. So any questions? Did we lose anybody?
Looks good. Thanks, Russ and Jacob.
Well, thank you. Well, with that, if anybody has any questions, feel free to reach out to your sales rep or to Jacob or I. We do have demos of the equipment. I've physically built these systems, so I know a bit about them. We'd be glad to work with you or to go over in more detail on these products, or come to your facility, because we are open for business as well. So with that, if we don't have any more questions, we'll end the webinar. I can't hear you, Jake.
All right. Thanks, everyone. We'll let you all get on with your week. Have a great week.
Thanks, guys.